Hello, welcome to this week's video. We're going to continue our discussion of Alteryx functions. Alteryx has a lot of functions out there. It's good to know how you can use them, some examples of how they work, some of the minutiae or details about what the parameters mean, what they do, rather than just having to read through and guess on your own. We'll take time and talk about what each of these can do for us. If you haven't watched part one, because this is part two, part one, I had a much more in-depth introduction into the functions, how to use them, where to use them, and we went on to talking about the individual syntax. Part two, I'm going to spend less time talking about the logistics of using functions and just really delve into what these new functions are. So in part two, what we're going to be talking about is the conversion and string functions. Part one, we talked about a bunch of other function categories just to cover the rough base of them all. Part 3, which will be coming next, we're going to talk about the date and time functions. Alteryx has a very wide array of functions that extend what developers are currently used to seeing, making things much more simple in some cases and much more advanced in other cases. And while it's pretty easy for a developer to get used to how these functions work and how to interpret them because they have some baseline, a lot of times the business analysts don't like to delve into functions because they're not sure how they work or how to make them do what they need it to do, and they get frustrated. We'll try to alleviate that frustration. Unlike in part one, I do believe that when I walk through this, in part two, I have used every single function that we'll be talking about. I did not include all of the conversion or string functions, just those that are most likely to be those that you would like to use. There are some more advanced string functions, some of which I don't understand why you would want to use them, as well as there is some regular expression string functions, which I did not cover. They will probably be covered in a separate video if you have a need for that. So please subscribe. Let me know if you do want to see regular expression videos. Comment whether this is going to help you or not, and I can cover those in future videos. But first, let's talk about database views. In the part one, we talked about how to denormalize your relational data, such as stored in a third normal form or a dimensional model in a database. And in that we used a macro, and that made it so that anyone could call that macro and it would return the data in a very nice denormalized flat structure, so you didn't have to do all of the Alteryx workflow steps. And I did mention how if you had access to a database and your data was stored in a database, you could actually create a database view that would do the same thing, and it's sort of your choice as to how you would do that. In this video, before I began doing my functions, I went ahead and created a view that was denormalizing the puppy training fact just as the macro did. And I thought we would take just a moment and walk through that. How do you create a view? Well, the view is actually the instantiation of a select statement. So first you need to develop and to complete the select statement. Make sure it works before you try to create the view that surrounds it. And in this case, I went ahead and created the denormalization of the Daisy Hill Puppy Training Fact Data Mart. When you're creating a multi-table join, I always recommend that you do it one join at a time, not giving it all, trying to write the whole thing and debug it when something goes wrong. So what I did first is just simply started with the training fact table, made sure that the query worked for that, and then I started joining one of the tables at a time, testing it after each one. We ended up with the 1, 2, 3, 4, 5, 6 different dimensions. This query looks pretty simple and straightforward, mainly because I adhere to a nice database standard that I like to use that makes such a query easier to write, but you need to understand how your data needs to be joined together. If you have any questions, you need to talk to your own data architect or DBA to understand how all this fits. And as I added each piece into it, I decided which of the attributes or columns I wanted to return as part of the view, so they were in the select statement as well. Changed the name of a few, and I like to put them in alphabetical order except for the primary keys that are applicable, or in this case, just the primary column that is used within the puppy training, which is the puppy's ID. That being said, once I did this and I had it down comfortably so it worked, as you can see here, executing it returns the data that I need in a very efficient manner. Then all that I want to do is go ahead and put a create statement at the beginning of it. MySQL allows me to have a create or replace view, so I can create or replace the view Puppy Training view. I put the word as, and again, the syntax that matches your database must be adhered to. This is the syntax for MySQL. It is also probably the syntax for a majority of the RDBMSs, but check with your RDBMS to make sure you get your create view statement in the proper form. Also make sure that you have access to create a view in your database. Again, I have full access to this database, so I have carte blanche to go ahead and create these objects. You may need to engage a DBA or a data architect to get this accomplished for you, whoever it is that might be managing a semantic layer if you don't have access to create it. That being said, once I put the create up here, I can now execute this, and you can see down the bottom here it shows that the view is created. The view also appears over here in my navigation tree, and there's the Puppy Training view. This is what we'll be using inside of Alteryx to access this data. So inside of Alteryx, views are seen the same as a database or treated the same as a database table. So we will drag in our input data, associate our input data with the MySQL database that I use. Now right here, I can just type in the name of the database, but I also wanted to go ahead and show you that here within tables, the views will appear in the same tree. Where they appear might be different depending upon which RDBMS you are using. For my SQL database, it appears just in the same ordered list as the tables. And down here is my Puppy Training view. I can click on it, and this will access the data and get it running down to it. Keep in mind that when you click on that table, it actually turns it into a select star from table name. I myself, just to keep with my own standard, like to simply reference the name if there's nothing else in the query other than one single table or view. I like to put the database at the beginning of it and not use the individual quotes. Test the query once I like the name. You can see no errors are found. I can click the OK. I can now run this. It will access the MySQL database, reference that view, which will then in turn execute the embedded SQL select statement and return the data back to me so that I can begin to develop my functions using this subset of data that has a number of different data parts to make my functional generations or examples much easier to create. So we will start this by going to a workflow that I've already created, and we'll talk about each of the functions in turn, showing you what the data looks like on the outbound side once the functions execute. If you have any additional questions about functions while I'm walking through this, go ahead and write them down, drop them in a comment. Subscribe to my channel. Let me know what you like, what you found confusing, and any additional information and help you might need. That being said, let's get ourselves started. What I have done with this workflow is to bring in the Puppy Training through the view. You can run this again. You can see how very quick it is in going through this whole process. This is due to the fact that no matter how many branches you have and how many different formula steps you have, Alteryx processes it one row at a time. So it's very efficient to run all those rows through. To make it a little bit simpler, I've only requested some of the columns out of the view. We'll be dealing with puppy name, breed name, and kennel name. To make it simpler to look at as well, I went ahead and retrieved some of the unique records out of here just so that it is easier to see the results. And then I broke it down into 3 subsets of formulas so that the configuration of the formulas themselves are not that long. So let's start at the top. And again, I can make these bigger. I have to do it individually. So let's start talking about it. ToString. ToString converts a number into a textual string. You can add thousand separator, and you can use decimal support. So in this case, we said that we want 2 decimal places. We do not want a thousand separator, and the decimal will be a period. When you run that through, you can see that here at the end, we have the, slide back a little bit, we have the month number, and when we convert that to 2 digits, we get 1.00 since all these are integers. So we can determine what degree of accuracy we want to have when we convert that number into a string. Now let's go ahead and take that month number text and convert it back in to a number. Since I did not have a textual value that was numeric, we went ahead and used this one. So we're going to take the month number text, adding a 1 onto the end of it so that we actually can get some decimal places out the other side. And we use the 1, which is ignore errors. We want to keep nulls rather than turning them to 0. And we want to use period as the decimal separator. Having run that through, you can see that our month number text float, because our data type out is a float, becomes numeric and has the degree of accuracy of the data coming in. If we want to take that into a text field, in other words, let's take the numeric value and turn it into an integer, we will simply give it a 0 for the number of decimal places and take the other defaults. In doing that, our now string comes out just to be an integer. And if we want to go ahead and turn that month number text, which is what we started with up here, and turn it into an integer, 2 things that we do is now we'll just convert it to a number with all the defaults, and then put it in a data type of int. And that gives us the floating point number back out as an integer for our textual output. Some very simple ones, nice to use depending upon data that comes in. Keep in mind you can also directly convert numbers to text and text to numbers just by changing their data type, but if you want to control the accuracy and the methodology, it's good to be able to use the 2 strings and the 2 numbers as also so that you can handle some specific situations. So that's the conversions that we wanted to talk about in this video. Let's go on to the kennel names. We have some to talk about. One returns a Boolean, as you can see, and that is the contains string function. It basically says that if the kennel name is dog or contains dog, it will return a true. And the 0 goes ahead and says that it is not case sensitive, which is the default. We can put a 1 in there to be case sensitive if we need to. And you can look at this and see that if you see the kennel names, take a looking at the results. One down, one too far. So here we have the kennel name. And the fields associated with it. Kennel contains dog, true or false, for the individual kennel names. And again, it is not being case sensitive because of the 0. We can also count the number of words. Those are textual tags that are separated by a white space, and we can see that the kennel word counts are 1s, 2s, and 3s depending upon the kennel that's coming in. It's nice to know what is inside of this, especially if you're trying to do some post-processing of the records, if you have a raw textual format that you're trying to convert in. We have the choice of checking for EndsWith. That determines whether or not the text string ends with the word kennel. It returns a Boolean for true if the name of the kennel includes the word kennel. By default, this runs as case insensitive. And we can also put a parameter on there to be case sensitive. We also have the check as to whether or not the kennel name starts with the word dog. So this will check the very beginning of the text string. If it includes dog, it will return a true, and otherwise it returns a false. And again, just like with EndsWith, the StartsWith by default is case insensitive, but by pasting a 0 on there, it makes it case sensitive. We have the FindString function, which will find a specific string and tells you where that string is found within the text. It is by default case sensitive and does not have an option for turning it case insensitive or not. You also need to understand that wherever it finds the string, it starts counting string positions at 0. They have an explanation for this that really doesn't make a lot of sense within the documentation. I tend to think of this as the default for C programming, which is that you begin strings with position 0. So if the first character is indeed matched within that string, then it would return a 0. We take a look at this very quickly as the results set. You can see how this plays out. So if it does not find the string, it returns a -1. If it returns the string, it tells you within there where it finds it starting at 0. So you can see that dog's mine. The O is the second character, and it returns a 1 since it started counting at a 0. The D is 0. The O is 1. So finding OG says it found it at position 1, which is the second character. I know that's confusing. It's the way it works. Two more to round this out with as far as for kennel name, GetWord. What we're telling it here is to find the word within this string, or a specific word within the string, by position. And you notice that again, it starts counting at 0. So if you want to find the first word in a text string, you give it a value of 0. If you want to find the second word, you want to give it a value of 1. So you can see that we're looking for the first word, we gave it a 0, and then it returns us that first word within the kennel name. So if we want to find the second word in the kennel name, we want to go ahead and pass it the parameter of 1. So the second word is 1 because we start counting at 0. Again, I know that that is confusing. It's the way it is, and it's just nice to be able to understand that and keep with it. The second set of string functions, we're going to be looking at the breed name and finding out and manipulating what's inside of there. As you look at the results set, you can see we're going to do a number of things to breed name. So let's start looking at them. The length function simply tells us how many text strings are in this. Surprisingly, it starts counting at 1. So if you have 7 characters, it will tell you you have 7 characters. It doesn't do zero-based mathematics within the length function. So we can look at our breeds and see that we have different lengths associated with them depending upon what the breed is. If we want to find just a subset inside of the text string, we use the Substream function. In this case, we want to start at character 2 and see a string length of 3. Keep in mind that it starts counting at 0, so this is actually the third character in the string is referenced by 2. Again, sorry for that, it's the way it works. So we want to basically see the third character for a length of 3 because we start counting at 0. We look at the results, you can see that here breed name 2, 3. So Bulldog starting at character 2, which is the third character, is 0, 1, 2. We have the L for length of 3, which is LLD. So the substring of breed name 2, 3 starts with the physical third character, starting counting at 0, and gives us 3 characters afterwards. If we want to see just the left 3 characters, as you can see here, left 3, we simply use the left function, give it the string, and give it 3 characters for the length. It will give us those 3 characters, starting with the first characters. And we have the other side of that, which is the right, which takes the right 3 most characters. So for Bulldog, the right 3 most characters are DOG, and you notice it adjusts for the length of the string. The last 3 characters for Oxer is XER. We have functions that allow us to change the length of the string. We will be using this when we start to do some of the date functions. But for simply in this one is that we want to pad to the left side of the string using spaces to the length of 15 characters. So you can see there's a single space in there. So the breed name of Bulldog padded to the left puts characters on the left until each one becomes a length of 15. You notice the warning here is that there are leading spaces in it, just so we know. We also have the PadRight function, which puts characters to the right-hand side of the text string. Again, you can put any character you want in there, so we're going to use the underscore just to show the difference. And so we want to put underscores to the right of the breed name until the length of the string becomes 15. And you can see, depending upon the length of the string, a different number of underscores are put in there. So Boxer has more than Poodle. So then each string will be padded out to 15. We can go ahead and remove extra text that we do not need. Good way to remove blanks that are at the beginning or end of a string. I'm trying to make this look a little bit easier to see. The trim function removes characters from the left and from the right of the text string. While you're allowed to give it a string that contains a value or a set of values to trim from the text, by default, it defaults to any white space. So trimming breed name PadLeft removes any spaces on the left or the right of the string. This basically returns it back to where we started. We can also trim from the right. In this case, we want to go ahead and remove the underscores from the right-hand side of the text string that we had created earlier. And keep in mind that you can put one or more characters inside of the text string that identifies what to trim. So the TrimRight removes the underscores from the right-hand side. Continuing down, TrimLeft, we can trim the spaces that are inside of the one that we had left padded. And that then goes ahead and removes those leading spaces that were inside of our string. This essentially does the left-hand side of the string. And just for the fun of it, we wanted to go ahead and show you that you can remove a variety of strings from the left or right should you have that need. So we trimmed the breed name and used uppercase B and lowercase r because this is case sensitive. So remove any leading B's or trailing R's from the breed name. So you can see that the B is gone from Bulldog and the R is gone from Rottweiler. The other R's and R's at the beginning are left alone because this is a capital R and it is case sensitive. So it will trim R's or capital B from the end and R or capital B from the beginning, if that you have the need to do. In the third part, we're going to do a little bit of manipulation of the puppy's name. Mainly we'll be working on replacing strings from the names. So we're going to go with the ReplaceChar. And what that does is in the text string puppy name, it will remove and it will replace any S's with an underscore. So for the puppy name, we look down a little bit, we can see there we go. So the puppy name of Francis gets the S replaced with an underscore. It is a single character and case sensitive, so we simply will be looking for any string and replacing it with a single character. That's sort of a subset of the other replace, which is simply to replace within puppy name anywhere you have a PH and replace it with 2 underscores. You notice I just wanted to go ahead and show that you can use single quotes or double quotes at your leisure. That is helpful if you want to replace double quotes, you can surround it with single quotes, or if you want to replace a single quote, you can surround it with double quotes. So anywhere that there's a PH, we want to replace it with 2 underscores. So it seems that Josephine has the PH removed in the middle. And then we have ReplaceFirst. And again, it can be multiple strings. And I just wanted to go ahead and show you that you can get a little complex within your functions. We talked about this earlier, which is that you don't have to do just one function, but here I've nested a function within a function because what I want to do is show you 2 examples of ReplaceFirst without having to do 2 separate variables. So replace first in the puppy name. We're going to replace a 0 with a question mark. Once we've resolved that, we're going to go ahead and replace within that new string the first A with an A within an open and close parentheses. So here we can see that Linda has the A inside of parentheses and Joseph has a question mark. It's giving you two different examples of the replace first. So you can see that it works with multiple characters, as well as how you can get a little bit more complex within your strings. So that's the end of this video. I hope it helped you understand a little bit about functions. Please refer back to them, especially in those functions where you have to learn to start counting at 0 rather than 1, because it's just in a few places that you have to understand that that applies. If you have any more confusion and any more questions about any of the functions that we've talked about as far as conversion or strings, please drop me a comment, subscribe to my channel so you can be informed when I complete part 3, which is an exciting video to talk about the many different date time functions that Alteryx supports to help you with your date time manipulations, because so much reporting is based on date and time. Let me know if you like this video, drop some comments. Otherwise, have a great day.